Hello everyone, welcome to another video of General Mathematics of Class 9, and today we are going to do polynomials. That is chapter 2 of your book. So first of all, before we even start with what are polynomials, let us start with something else, something that is related to this. And the basic stuff, the very basic stuff of polynomials. The first thing we need to know is what are terms, okay? So suppose I write a number 2 and I ask you how many terms are there. Obviously, only a single number is there, so it is a single term. So one term is there. Now if I write twice x and ask you how many terms are there, and at the same time I write twice x plus 1, how many terms are there? So here what we have done is we have multiplied 2 with x. So this twice x being a number, here 2 and x are the factors of each other. Okay, so 2 is the factor of twice x is also the factor of twice x. So when we multiply, or let us say we write 2 by x or twice x, or we divide. So here also these numbers, these are factors. 2 and x are two numbers which are divided, x is dividing 2. Okay, we don't know whether x will be a factor of 2 or 2 will be a multiple of x, but here these two are being divided and here we have multiplied. So whenever we multiply any number or we divide them, they always form a single term. So here also we have one term. Here we have something called twice x, where 2 and x are factors of each other and they form a single term, and 1 forms another term. So here we have two terms. Okay, so here 2 contains single term, twice x or 2 by x is also a single term, but twice x plus 1 gives us two terms. That means, what do we understand from here? That if I write any two numbers or multiple numbers and I multiply all of them or I divide all of them, then they will always form a single term. But if I add or subtract different numbers, then each of them become terms. For example, I write 5 plus twice x minus 3y plus 9 z. What do we have here? What we have here is 5 is a term, twice x is a term, minus 3y is a term, and 9z is a term. Okay, so this positive and negative signs, there is addition and subtractions. These are the operations which will separate the terms. So 5, twice x, thrice y, 9z, these are four different terms, and 9 and z, they do not form two different terms, they are a part of the same term because they have been multiplied. 9 and z are multiplied. So multiplication, or suppose I write 2 by x plus 5 by y plus 3 by z. Here 2 and x have been divided, 5 and y have been divided, 3 and z have been divided. So multiplication or division between two or more numbers creates a single term only. So this is one term, this is one term, this is one term, but they have been separated by positive sign. Here these four terms have been separated by positive and negative signs, that is addition or subtraction. So addition or subtraction creates different terms, but multiplication and division do not create separate terms, they form a single term. So now let me give you another example and you will tell me, try to guess before I give the answer. You will try to guess whether they are having multiple terms or a single term, or you will tell me how many terms are there. Okay, so suppose I write x square plus x, then I write y plus y square plus 4, then maybe t square minus 5. Okay, so three examples. So what do we have here? Here now I hope you have already guessed the number of terms in each of these cases. So in the first case, we have x square and x separated by a positive sign. So this is one term, this is one term. So it is two terms, right? Hope you got it correct. Here we have y square and 4 separated by two positive signs. So we have 1, 2 and 3 terms. T square and 5 have been separated by a subtraction sign. So here we also have two terms. Okay, I hope this part is clear. Now we move on to something else. So now that we have understood what are terms, let us understand what are the different types of expressions that we can have. Now what are expressions? All these things that I have written, this one, these three, these are all different mathematical expressions. Now expressions can have multiple number of terms. If they have a single term, for example x square, this is a single term. This is called a monomial. Mono for a single. Mono means single. So single term containing expressions are called monomials. If they have two terms, suppose x square plus x, this is called a binomial. Bi means two. If they have three terms, they are called, suppose x square plus y plus z, whatever we want to write. Three different terms, these are called trinomials. Okay, and this will go on like this. So any mathematical expression containing more than two terms, means containing multiple terms, are called polynomials. So here we come to the name of the chapter, polynomials. Polynomials means a mathematical expression containing multiple terms. So multiple terms will constitute a polynomial, even containing more than one term basically. So if we have two terms, this is also a polynomial, this is also a polynomial. Okay, single term containing expressions are called monomials. These are not poly, because poly will take into consideration more than one. Okay, so now let us move on to something else which we call coefficients. Now what are coefficients? So coefficient of a term. So suppose I write 2 x square. Okay, so here the variable is x and 2 is the constant number. So here 2 is the coefficient of x square. Okay, that is how we define coefficients. Means the term associated with it, I mean if we have a single term, the constant is the coefficient of the variable. And not only this, in this case only we have one single constant and one single variable. That's why we are writing 2 is the coefficient of x square. Also x square is the coefficient of 2. It's like, who are the friends? If I ask you, there are two friends, friend A and friend B, then A is the friend of A and B is also the friend of A. A is the friend of B, B is the friend of A. So in the same way, in 2x square, 2 is the coefficient of x square and x square is the coefficient of 2. Now if I write 2x square y and I ask you, what is the coefficient of x square? Means other than x square, what are the different terms we have here? What are the different values that we have here? So the coefficients will be, so what you will do here, you remove x square from the consideration and whatever you left is your answer. So 2 is left and we have y. Okay, so that means who in a single term, if I ask you to find the coefficient of x square, then you will see other than x square what are the partners. So partners of x square are 2 and y. So therefore twice y is the coefficient of x square. Similarly the coefficient of 2. Coefficient of 2, that means you remove 2, other than 2 what do we have? X square y. So x square y is the coefficient of 2. So in the same way, coefficient of y, what will be the coefficient of y? Remove y and see what is left. It's 2x x square. So 2x x square is the coefficient of y. I hope the coefficients idea is clear to you. Okay, now we will move into another concept which is called the degree of a polynomial. Now what is a degree? So let me write one expression, one polynomial. Suppose x square plus 2x plus 5. Okay, what we have to do first is see what is the variable. The variable here is x. The next thing we need to check is what are the powers or what are the exponents of the variables. Here there is no exponent, means the exponent is 1. Here the exponent is 2. So the degree of the polynomial is the highest power of the variable, highest power. So here the highest power is 2. So therefore degree is 2. Okay, let me write another one. Suppose x cube plus 2y, 2x minus 5x to the power 2. Okay, x cube plus 2x minus 5x to the power 2 or 5x square. So now again here the variable is x. What is the highest power? The highest power is 3. Therefore degree is 3. Okay, so now we have different types of polynomials. One is linear, then we have quadratic, we have cubic, etc. What does this mean? If the degree of the polynomial is 1, it is linear. If the degree of the polynomial is 2, it is quadratic. If the degree of the polynomial is 3, it is cubic. For example, this one, the highest power is 3, so it will be a cubic polynomial. Here the highest power is 2, so it will be a quadratic polynomial. If I write suppose if I write x plus 1, highest power, x is the variable, the power is 1, so highest power is 1, so this will be a linear polynomial. So whatever is this linear, quadratic and cubic depends on the degree of the polynomial. If the degree is 1, it is linear, degree is 2, it is quadratic, and degree is 3, it is cubic, and similarly it will go on further. So these are the basics, the theory of this exercise that we are going to start now. This is exercise 2.1. So I hope you have understood this. If you have not understood, make sure you go back into the video, check which parts you have understood, try to see them again, then come back to the exercise. So now what we are going to do, we are going to start the exercise. So exercise 2.1. And let's see what we have here. So in the first question number 1, what has been given? So take out your book, take out question number exercise 2.1, question number 1. What do you have here? Which of the following expressions are polynomials in one variable and which are not? State reason for your answer. Okay, I think one thing I missed here. Let us check it out again. For an expression to be called a polynomial, the power of the variables must be whole numbers. The powers cannot be fractions or negative numbers. Okay. So if I write x to the power minus 2 plus 5, this is not a polynomial. This is not a polynomial because the power is negative. The power or the exponent needs to be a whole number. Whole number means 0, 1, 2, 3 and up to infinity. So either all the positive numbers or 0. If I write suppose x to the power half plus 2, here the power is half, so it cannot be a polynomial. Okay, so the powers must be whole numbers. Anything other than whole numbers, it will not be a polynomial. I hope that is clear. Now let's move on to the exercise. So what we have here, state reason for your answer. So number 1, it is given that 4x square plus 3x plus 7. This is the polynomial given, the expression is given. So you have to say which of the following expressions are polynomials in one variable and which are not. State reason. Polynomials in one variable means here what is the variable? Variable is x. So since we have a single type of variable, this is a polynomial in one variable because only one type of variable is there, that is x. Don't consider the powers. Powers will be different for different terms. So what we need to see is if the type of variable is a single type. So here only x is the variable, so it is a polynomial in one variable since there is only one variable, that is x. Okay, very simple. Let's see another one. Suppose number 2, try to guess the answer. Y square plus root 2. So variable is y. And there is only a single type of variable, there is no other type of variable. So this is also a polynomial in one variable, and you can write the reason like this, since there is only one variable, that is here we have y. Okay, let's move on to another one. Suppose number 3. 3 into root t plus t into root 2. Now what is this? This is not a polynomial. Why not a polynomial? Because here t's power will be half. Root means 3 into t to the power half. This is the square root. Square root means power half plus t into root 2. So here the variable has a power in fraction. So it is not a polynomial, as the exponent or the degree, or you can write the exponent of the variable is not a whole number. Okay, I hope that is clear. It is not a whole number. So as I said previously just now, that in order for an expression to be a polynomial, it has to contain the variables must contain the powers as whole numbers. Okay, let us see one more. Suppose let us see this one, number 4. I am doing it here. Okay, y plus 2 by y. Now you see, you might be asking that this should be a polynomial, but no, this is also not a polynomial. Y plus 2, this is divided by y, right? So that means the power of y is 1. So if I bring it to the numerator, the power becomes minus 1, right? So when we write the reciprocal and we get an expression like this, here the power of y is actually minus 1. It was divided, that's why it seemed to be 1. But actually the power of y here is -1. So -1 means it cannot be a polynomial. So it is not a polynomial. Okay, and the reason is like this, that not a polynomial as the exponent of the variable is not a whole number. It is a negative number. So it is not a whole number, it can't be a polynomial. So similarly we have number 5. Let's see number 5 as well. We have x to the power 10 plus y cube plus t to the power 50. This is a polynomial, alright, but this is not a polynomial in one variable. The question has been asked, which of the following is a polynomial in one variable? But here we have 3 different variables. X is a variable, y is a variable, t is a variable. So 3 different variables are there. So it is not a polynomial in one variable, as we have 3 different variables, x, y and t. Okay, that is how we solve question number 1. Moving on to question number 2. Let's go. Number 1. What do we have? We have 2 plus x square plus x. This is the expression given. So write the coefficient of x square in each of the following. So you have to write the coefficient of x square. So you have to find the term which contains x square first. So here we have the term containing x square. So coefficient of x square will be, what is the coefficient? Do we have anything with x? What is the factor of x here? Factor of x is 1. We have nothing written here, means it is obviously 1. So coefficient of x square is 1. Let's see another one. Suppose this one, 2 minus x square plus x. Here the coefficient of x square will be, so with x square we have only a negative sign, so no number. So it is obviously -1. Let's try one more. Number 4, root 2x minus 1. So coefficient of x square is equal to, with x, do we have an x square here? We don't have an x square here. So coefficient is 0 because x square itself does not exist. And finally number 5. So what do we have to do with 5? It is 2x minus 3 into x square minus 3x plus 1. So these are 2 different factors. So to multiply them, we have to simplify this and then find the coefficient of x square. So let's multiply. 2x into x square is 2x cube minus 6x square plus 2x minus 3x square plus 9x minus 3. So here we have 2x cube, x square, so it is 9 minus 9x square plus 11x minus 3. So now we have a polynomial, and here the coefficient of x square is -9. So coefficient of x square is equal to -9. Done. Simple. We are done with this. Let's move on to question number 3. Moving on to 3, what do we have? Give one example of binomial of degree 35 and a monomial of degree 100. So binomial, of degree 35 is, binomial means we have 2 terms. So let's choose any variable, suppose x. So we can write x to the power 35 plus 2x. Done. We have variable x and the highest power is 35. So and we also have 2 terms. So it is binomial and degree is also 35. So there is one example. And one monomial of degree 100 is simple. Let's write x to the power 100. One term, and that very term contains the power 100. So it is a monomial of degree 100. Done. Now let's move on to question number 4. In this we have to find what is the degree. The degree we have to find. So we have 5x cube plus 4x square plus 7x. So the degree is equal to, so what we have to do, degree means the highest power of the variable. So the highest power here is 1, is 2, it is 3. So highest power is 3. So degree is 3. Similarly, let's move on to number 2. It is 4 minus y square. So degree will be, we have variable y, highest power is 2. So degree is also 2. And similarly, let's do number 4. In number 4, we have only 3. Is there any variable? There is no variable. So therefore, degree of variable is of course 0. No variable, so degree is 0. Done with question number 3. Moving on to question, I think this was question number 4. Yeah. So now we are up to question number 5. The last question. So what has been asked? Classify the following as linear, quadratic and cubic. So as I said, linear means degree must be 1, quadratic means degree must be 2, and cubic means degree must be 3. So let's see. Number 1. it is x square plus x. So we have highest, the degree is 2, so it is a quadratic polynomial. Okay, simple. Find the highest degree. If the highest degree is 2, it is quadratic. Let's see number 2, it is x minus x cube. So here the highest power is 3, so it is a cubic polynomial. Done. Next, suppose let us do number 5, 3t. 3t, only one variable, and there is no power, means the power is obviously 1, so it is a linear polynomial. Okay, so check for the highest power. Whenever you get the highest power, try to see what is the power. If the power is 1, it is linear. If the power is 3, it is cubic. If the power is 2, it is quadratic. So that's where we come to the end of exercise 2.1. I hope you have been good with this chapter. Very easy exercise. Just the basic things you have studied. If you understand this, you can move ahead to exercise 2.2 and understand better. So thank you everyone for watching. And if you have any confusion, make sure you ask me. Okay, don't feel shy. Make sure you ask me in the comment section, or you can ask me directly. So thanks for watching, and until next time, cheers.